Okay, so as we're getting started, I just want to see how things are going in terms of how many people are having trouble with the VM. So I'm going to do a little survey here. Can you raise your hand if you are a Mac user and you were able to successfully get the VM working? Okay, so maybe 6 or 8 of you. And if you're a Mac user and you were not able to successfully get it working? Okay, so everybody on a Mac got it successfully working. If you're a Windows user and you're able to successfully get the VM going, raise your hand. Okay, so 5, 6, 8 of you. And if you're a Windows user and you've tried but have not been able to successfully get it working, raise your hand. Okay, so I know raise your hands. It's not your fault. Yang, I know you're supposed to be raising your hand, so raise your hand. All right, raise your hands. Tianya, I know you're raising your hand too. And what's your name?
Actually, it's working now.
It is working.
Yeah,
okay.
I'm not sure whether they are working or not.
Okay, all right. So do let us know if it's not working. Yang, I've already been talking with you, and Tianya, come talk to Jared or me if you're not able to get it working.
Can I just use Sigwin?
Yeah, you can use Sigwin if you want to, but I want to make sure that people have the ability to do something that is really just going to mimic what I'm doing. And Sigwin may differ in certain respects, and I don't want to have to, basically I don't want to have to get too involved and worry about whether you can get all the software you need on Sigwin compared to on a more on a platform that's more common to all of us. Okay, well that's good. I know some of you spent a bunch of time trying to get that working, so I appreciate you being patient and working through that, and I'm sorry that was a bit of a hassle. Okay, so in terms of announcements, a couple things up here. As I mentioned, the Piazza announcement, if you are interested in having another one of the R sessions, we're happy to do that. Just email Jared per the announcement, and pay attention to his announcement about GitHub and doing that before section on Monday. And yeah, he'll be talking about, I'm not going to go in, so section, I guess 14 of Unit 2 is a long extended thing on version control, and basically Jared is going to be working through version control with you on Monday. And also talking some about submitting the problem set and doing formatting and things like that. Okay, so let's pick up where we left off. And so I'd left off, I'd sort of shown you some of the helpful command line Unix utilities, and I'd started to get into this idea that you can chain them together to do much more powerful things than you can do with any single one of them. And I asked you for today to just play around and see if you could just get a feel for some of them. So I'm gonna turn to my panel for today and just try and get a sense of sort of what people played with and what worked and what questions they had. So JR, I see you're here. So what did you find out about cut?
Sorry, I haven't been. I thought this was for next week, so.
Okay.
Yeah.
You thought the homework was for next week?
Yeah, I thought this was, I had to be wrong.
Okay.
But, yeah.
Okay. So you didn't get a chance to look at the utilities?
Not. Yeah, I haven't played with it. I was playing like stuff before, so I haven't gotten to like the cut.
Okay.
But I saw an idea of what piping is.
Say that again?
Oh, I have a sense of what piping is, but I don't know what the specific comment.
Okay. All right, so let me turn to so Yang, did you get a chance to look at any of those?
Well, I only got a chance to play with the star one.
With the what
The
one?
star.
Star.
The LS star. And then this
Oh, okay. Did you get a chance to look at any of those guys? No? Okay. Did anybody on the panel get a chance to look at any of the utilities? Yeah, Daniel.
In the context of the homework, does that count?
Sure. Just give me a sense for it. Was there anything that sort of surprised you or tripped you up, or did you find anything useful as you were looking through some of the commands?
Cut, changing and delimiter cut is very useful.
Okay, so how do you do that?
Dash D option is trying to make codes for what you want.
Okay.
Or type in man and then cut.
So so it's something like cut and then minus D and then what did you do?
Single quotes and then whatever you want the delimiter to be.
Okay, so you could put a comma in there.
Type.
Okay, yeah, or you could also put a pipe in there. Sometimes people will use pipe as a delimiter.
Correct is not case sensitive by default.
I think it is by
It is?
default.
Okay, then it's the dash I option.
Yeah, so grep has that's good. So that's a good one to know that there's a dash I option to grep. So I think by default, maybe it varies by what system you're on, but I think by default it is case sensitive, and if you do -I, then it's not case sensitive. So that's useful to know. All right, anything else anybody want to comment on about anything they played around with? And what's your name?
Greta?
Greta.
I guess I'm kind of confused. Is CUT supposed to output something to your screen or just editing the file?
It's outputting to your screen. So that sort of gets into this idea of standard input and standard output in typing. So by default, many of these things are just going to send their output to something called the standard output. And by default, standard output will print to your screen, but you can redirect the standard output into a file, for example, if you wanted to. So something like, in fact, I think for all, none of these are going to affect any file that you use them on. Okay? So it's all sort of, you have an effect on the output, and you can put that output somewhere else, but in general, they're not going to actually directly affect the file itself. Other questions or comments?
Well, I found a super useful one to be head.
To be what?
Head instead of tail.
Oh yeah, so head is basically just the reverse of tail. It just shows you the top of the file. Yeah. Any other comments, Kelly?
So something that was kind of strange or interesting, I thought, when you can do the output of the file with the greater than sign, but we both experienced this error or problem, I think, that you can't cut from you cannot have the same file name for input and output when you
Right.
use that.
Right.
And that was surprising to me. I thought that you would be able to read from a file and then like rewrite to that.
Yeah,
same
so
file.
for those of you who've looked at the problem set at problem 3, I have the use of another one of these utilities called sed, and that actually allows you to edit a file in place if you pass a particular.
We actually had the error and wiped the file.
Oh.
Because you had to use 2 arrows to append, otherwise if just 1 arrow is rewritten.
I was using 2, she used 1.
So that, yeah, so
Just have blank files.
that would be a good thing to post a comment on Piazza. I'm not going to be able to diagnose it right here in front of you, but it would be good to see if other people have that issue. Okay, so let's now turn to this idea of continue this discussion of redirection. So we saw a little bit at the last time about piping and basically sending the output from one command as the input to the next command and chaining these things together. And then the greater than, the less than, and the 2 greater thans are basically if instead of sending the output to your screen, you want to send it into a file, or if in general, if there's something that is expecting input from your keyboard, you can instead use the less than to say, oh, don't use the input from the keyboard, don't use the standard input, instead take the input from a file. And then the difference between the 1 greater than and 2 greater than is am I supposed to append, which is the 2 greater than, or am I supposed to just write it out to basically to a new file and potentially overwrite the file that already existed, and that would be the one greater than here. So we'll see some examples of all of these in a second. So let's switch over to the virtual machine. I don't know why this keeps popping up. Okay, so here we are, and we've got these couple examples of using piping to get information about I just learned yesterday how to cut and paste in this in the VM, which is so copy is meta W, all right. W, and then paste is Shift Control V. All right, great. Okay, so here we're going to, where am I here? We're going to cut with the comma delimiter. We're going to take the second column or the second field of this file. And we're going to pass the output into sort. And so sort by default is expecting input from standard input. You can either say sort and then a file name, or if you don't give it a file name, it'll expect to get the input it's supposed to sort from standard input. So you could actually say type, and then you could say sort, and then you could use a little bit of syntax to then send in the input from typing. But if we don't give it a file name and instead we use the piping, it's going to get the input that's redirected from this output. and then it's going to sort it by line, pass it to unique, and then we're going to do the word counting. So this was the case where people were saying, oh, I got 24 versus 25. There were a couple of comments about this on the on Piazza, and hopefully people noticed that there was the row name was the 25th one, which is why there were 25 instead of 24.
I thought it was because of New Zealand. It's based in New Zealand.
Oh, that could affect things as well. So if we do the word count, so this should be lines. I think that this is lines, words, which would be separated by white space of some sort, I think, and then characters. So yeah, so I guess it's 24 including the country, and then 25 if New and Zealand are split. So yeah, and you can get more information on this just with man on the WC command. The other thing I wanted to point out here was this idea of redirecting into a file. So if we wanted to, instead of printing to the screen, we wanted to save this for some future operation, I'm going to redirect it into this file called countries.txt. And now if I do less on countries.txt, indeed, that'll just have the contents of what I just created. So those sorts of things can be quite useful. Let me just give you sort of a little bit more of an extended example of this that was a sort of real life example. And so I just logged into one of the SCF servers, and this is just a directory that I was using for some research a year or two ago. And this directory has thousands and thousands of files in it. It basically is weather data from many, many different stations across the world. So there's one file for each station, and there are thousands or tens of thousands of these things. So if you do ls, it'll just start printing thousands and thousands of file names. So I'm going to do ls, and then say I'm looking for all the file names that have USC in them, which are actually the stations that are in the United States, just by the convention of the naming of the files. And then I'm going to pipe that to less. So I can use less in this way just to sort of page through the file names. It looks like it logged me out. All right, so okay, so if I do, let's see here. I was going to do ls star USC star piped into less. All right, so it turns out it's having to filter through a lot of file names, but eventually it pops up and is sort of listing them out, and I can just sort of page down and see what they all are. And so here's an example of, it turned out that I realized in all of these thousands of files that there was a special coding character, capital S, that stood for some particular kind of error that was occurring in the data. And this was recorded by the people recording all the climate data. So for whatever reason, in this particular analysis, I needed to know if there were any of these S's in any of these thousands and thousands of files. And I needed to know if they were in these particular positions here in the file. So this minus B is going to basically cut by the character position. So if I did minus B1, it would pull out the first character in every row. If I did minus B2, it would pull out the second character in every row. So it turned out for whatever the analysis was, I needed to know if are there any S's in any of these, in the 29th character, the 37th character, the 45th character, etc. And I wanted to scan through all of these files. And so what I did was I said, okay, do a cut and apply it to all of the files at once, noticing the use of the wildcard here. So this is going to give me all of those files that have USC and then anything and then end in this extension. And then just look for the capital S and then pipe that into less so I can just page through it and look for it. And there's something like 5 gigabytes of files of data represented here, and this was able to sort of work through that in a few minutes and show me whether or not there were any of these S's there. So I won't do that because it took about 5 minutes to run. But the other alternative to this would presumably have been to open up Python or R or some other language, read in the data, pull out the columns that I wanted, look for the S's, and then I'd have to write a bunch of code to automate that. Maybe I'd have a for loop that would loop through all the files. But here, by doing it this way, this was just a one-liner where I just pieced together some of these modular commands. So I find in my sort of everyday work that this is really useful for just sort of doing these sorts of quick and dirty kinds of things. Okay, so that's a real-life example of when this sort of thing can come in handy. Any questions at this point? Okay. All right, so I'm going to go back to my home directory. So here's another example of piping. Meta W. Okay, so here I'm going to say, okay, let me find all of the file names that end in either capital R or lowercase r that have dot, capital R, dot, small r, and then I'm going to pipe that into head, which was the command that one of you just mentioned. So the ls-t will sort files in order of when they were most recently accessed. So this is basically going to, if I do ls-lt so that I can see it in long format, I can see, okay, these are now sorted by which ones have I most recently accessed from most recent to oldest. So this could be useful if I want to see what are the most recent code files that I've worked on. And so in this case I said, well, I just want to look at the top 4 because maybe there are hundreds of them in here and I just want to see the first few. So another example of piping and redirecting information. Okay, now here's another slightly different thing that we can do, which is grep is going to, if I wanted to, for example, suppose I knew I had written out some PDFs from these R code files, and I wanted to go figure out which of these R code files created some PDFs, because I was trying to figure out where did I create that PDF for that particular analysis that I was doing. So, and I knew that it was in a few of the most recent files. What I want to do is I want to do grep and then PDF, and then I want to do the grep for PDF in these recent files. So I need to find some way to pass the name of the files to grep. So that's the goal here. It turns out I can't just do a pipe to do this because grep is not looking for the file name to come from standard input. It wants the file name to just be like typed out there right there for it. So what I would be doing if I were doing this manually is grep PDF and then giving it the names of the files that I'm interested in. Say in this case library.r and biomass.r or whatever the file names were. And that should work. But I want to automate this so I don't actually have to manually type in the names of the files. So what I'm doing here is I'm saying, okay, I want to make use of the results of this ls command that was then piped to head. And what the backticks will do is basically create a temporary variable. And then that temporary variable can be used as input to the grep command. So that's what's going on here. And it's going to be equivalent to doing grep PDF and then writing out each of these 4 separated by spaces.
Sorry, can I just ask, what's the difference between the list function and the grep function? Because they seem to find the things that
The which function?
Search, the ls function and the grep.
Yeah, so ls is going to just list out all of the files in the current directory. Grep is only going to give you the pattern, give you the files and the lines in those files where it found the particular pattern.
But you said you could list out the files that is in R format. So you sort of it might overlap with some of the function of the grep, right?
Yeah, a little bit. I guess the main difference is ls is just looking to tell you what files we're talking about, whereas grep is actually pulling out the rows where the pattern is matched in the row inside the file. Okay, so we know that ls-t in this head will return these 4 values up here. Oops. And then if I want to then use those 4 file names in my grep statement, I have to do this. Okay, so now if I do that, you'll notice that, okay, what it did was it returned the rows from any of these 4 files that had PDF in them. It turns out in this case, that only occurred in 2 of the files that it found a lowercase PDF in there. But now I know that, oh, okay, maybe that's where it was that I was creating the PDF, and I'm looking for the R code that created that PDF, so this might have identified that that's the file to go look in. This is another way that I could have done that. I won't bother to go into xargs too much, but you could play around with that if you wanted to. And then another thing that you could have done here was instead of assigning the result of this ls-t into a temporary variable, which is what's going on here, and then the temporary variable is used immediately, I could have actually assigned the result to an actual variable that persists in the shell. And that's what I'm doing when I say files equals and then that. So this is basically executing this command. and then the backticks say, don't print out the results. Instead, send the results into a variable that I can then use later. So another equivalent way to do what I did here would be to make this variable called files. Make this variable called files, and then we can see what. And then if I say echo, and then I use a $sign to indicate, if I'm creating the variable, I don't use a $sign. If I'm using the variable, I do need the $sign, so that's a little bit confusing and kind of a hassle. But if I say echo and then the name of the variable with the $sign in front of it, it will show me what the value in the variable is. And in this case, it's now these 4 file names. And so I could then do grep PDF and then pass it that explicit variable, and that would give the same result back as what I did up here. Okay, so I think that's most of what I want to say for now about redirection and about sort of how different ways of passing information around. Basically, you're just going to sort of get used to this by practicing and doing the problem sets, and you'll start to get a feel for some of these different ways of operating. Any questions before I switch over to some job control stuff? And remind me your name?
Guang.
Guang. Right.
And so why is that the spaces, like, is it just because if you do a space between the equal signs, you would just treat it as like a command on it?
Why is what the space is? Sorry.
So you can't put in spaces around the equal sign.
Oh, yeah, I'm not sure why what the reason is why you can't do this. Yeah, there's probably a good reason that sort of makes sense of why it's not designed so that you can use spaces, but I'm not able to come up with it off the top of my head. Yeah, it's sort of a bit of a pain, but if once you remember it, it's not too bad. Other questions? Yes, and remind me of your name. Mike.
Yeah. It says that you cannot access the R you have in your such directory. Does that mean we don't have anything with that file extension, or there's nothing to meet whatever criteria you set?
It says you can't access what?
It says cannot access, so for me it says cannot access star.r. I'm assuming that's because there's no R files.
Okay, well let's see. So suppose I say ls star zzz. There shouldn't be anything like that in here. Yeah, that just means there's nothing. There are none of those. There's no files that match that pattern in the file name.
But I have some in there.
Oh, okay. So this was a trick question, huh?
No. My other question was, I don't think there's any files in there that say PDF or have PDF.
Oh, okay. So you're doing the grep and
Yeah.
So then it would say there's nothing that I can't find any matches, so it gives back the message presumably.
Sorry, I wasn't trying to trick you.
No, that's fine. Let's see here.
Is it a return message or just showing nothing?
What's that?
So if there's no files that end up with R, for example?
Yeah, so it'll often return a message something like this. Okay, so now I want to turn and talk a little bit about starting up a job on the machine that will run in the background and sort of monitoring jobs, and maybe you might have multiple jobs running on your machine at any given time. So this could be jobs running on your local hardware, on your laptop. It could be running in the VM on your hardware. It could be running on a remote server like one of the SCF machines. All of those things are going to be the sorts of things we're going to talk about. So I'm going to start up a little R job here, and I'm going to do it by using the echo command to paste this line of content into a file called code.r. So I could have created this code.r by opening up an editor and typing this in. I'm just going to do this from the command line, just for the sake of having this sort of all be part of the same mode of operating. Okay, so I'm going to do that. Actually, I think I'm going to do this in the VM. So I'm going to switch over to a tab here that has where I have the where I'm actually on the VM. Okay, so here I am. I'm going to create this file code.r. What does this file do? It just creates 10 to the 7th random numbers. It finds the mean, and then it does that many, many times. And the reason I'm doing this is I'm just trying to create a job that will run for a long time. So this is a job that will run for a long time, but will also use resources on the system. So we'll sort of be able to see what's going on in that way. So I'm going to run this job. So many of you are maybe familiar with using R command batch to run an R job in the background. This is another way you could run a job in the background, and part of the reason I'm doing it here is just to illustrate the use of redirection here. So here I'm saying run R. Don't save the R objects on closure when R closes into an R data file. So don't do that. take the input into R from code.R and send the output to code.R out. Okay, so I'm using this redirection that I've talked about already. So I'm just going to run this as an R job here on the VM. And you'll notice that when I do that, it basically doesn't bring me back to a prompt. And that's because this job is now running in the foreground and it's sort of occupying my shell. If I hit Control-Z, it'll send it into the background. It'll actually temporarily pause the job and it'll say stopped. And so right now the job is sort of suspended. If I want the job to keep going, but to do it in the background, I can now type BG. And this basically means, okay, I'm unsuspending that, I'm continuing to run it, but I'm going to return you back to control over your shell to go and do other things. So this job is now running in the background. If I wanted to stop it, I could hit, well, if I were in the state of where it was suspended, I could have hit either Control-C or sometimes you need to do Control-backslash to kill it. That won't work here because it's not running in the foreground. But if it were running in the foreground and you were basically in this position here, you could have done one of these and it would have stopped the job. I could actually resummon up the job by doing foreground, and now it's sitting in the foreground. And if I wanted to kill this job, I could do Control-C, and it says, okay, execution halted and the job has stopped. So that killed off the job in this case. I'm going to restart the job, and if I want to directly put it in the background and not have to deal with this whole putting it in the background and restarting it, all I need to do is just put an ampersand at the end of the command, and that will start up the job and put it in the background and return control over the shell to me. So I'm going to do that. I got control back. This means that the process ID for the job is 1953. That can be useful for manipulating the job later on. And if I use a command called top, that will show me that indeed I have a job running on this machine. It has the process ID that we just saw. The user is this ASCII user, which is the default user on the VM. And it's using about 100% of the CPU on the VM. So it is a job that's doing a fair amount of computation. It's computing a whole bunch of random numbers, right? And it's using some chunk of the memory on the machine, about 10% of the memory on the machine. And the command that was used for starting the job was R. We can also see there's not really a lot more going on in the VM. There are a bunch of these sort of background processes that are being run by the administrative user, the root user. And that's sort of all it shows me. But if you want to know what's going on a machine, on a Mac or a Linux machine, running top will give you a good overview of the different processes they're running and how much in the way of resources they're consuming. I could directly from here, if I wanted to kill that job, I could type K, and the K brings me up to this little interface here, and I could actually type 1953 and kill off the job directly from here. In this case, I think I won't bother. I'm going to hit escape. I'm just going to hit Q to get, well, do I have to hit escape again? Yeah, I'm going to hit Q, and Q will get me out of top. Oh, it looks like I did actually kill it. All right, I didn't mean to do that. We'll restart it again. Okay. Let me see what else I want to say here. If I do want to kill a job, I can just type kill and then the process ID. In this case, the job that I just started is now job number 1956. So I could kill that job by typing kill 1956, and that would kill the job off. So if I started it and decided it wasn't doing what I wanted it to do, I could go ahead and eliminate it. And then another useful command is PS, which will also show all the different processes running on the machine. One set of flags that are often useful is PS minus AUX, and that'll show a sort of long list of the different processes that are running. Okay, so this all just flew by very quickly, and I wasn't able to see sort of all the things that were going on at the top. So how would I be able to see all of this without having it just fly by on the screen? Okay, I could send it into a file, one option. What else? Okay, I could pipe it to less. What else? Anything else? I could use head. There are probably other things I could do, but those are sort of the main things that I might do. So if I pipe it into less, I can see, okay, it turns out at the top it's listing a whole bunch of these sort of background processes, and then down below it starts to give more of an indication of sort of some of the more interesting things that are going on. It's a little hard to see because we've lost the header line, but this is the CPU usage and the memory usage for the job. And again, this is that same R job that I'm running. In this case, it gives me a little more indication of exactly what's running. In this case, it gives me the whole path to the R binary executable.
Is there a way to keep the headings while you move down the page?
That's a good question. I do not know offhand. It's something I probably should have looked into because I always find this to be frustrating, but I've never actually gone to see. There might be, that would be a sort of thing where if you did man on PS, you might be able to page through the various options and see if that's included in the options. Okay. Let's see. I think the last thing I want to mention here is a little bit more about this idea of looking at memory usage. So one thing to look out for when you're running a job is to make sure that you're not collectively over the different jobs that you're running, that your memory usage is not creeping up close to 100%. Because what's going to happen if it creeps up close to 100% is the job is not going to fail, at least not immediately. What's going to happen is the computer is going to start using disk space as RAM. And it's a lot slower to access disk space than it is to access RAM. And so anytime the computer starts to try and tries to use RAM when it's in the state of using basically of exceeding the exceeding the RAM on the hardware, it will start doing this thing called swapping or paging, where it starts to use the disk, and that gets really, really slow, and often your job will basically slow down to a crawl, and so much so that it may never finish. So you want to sort of keep an eye out for that you're not using up a huge amount of memory on the machine. Daniel?
I know Linux will do that. Will Windows machines use swap space as well?
I would imagine so, although I don't know for sure. Yeah. So we'll talk a lot about memory use in a few weeks, but it's a good idea to have some basic idea of how much memory your program is going to use, either by knowing by sort of getting an estimate beforehand, or by starting up the job and then sort of watching and seeing what happens and sort of monitoring the job when it's first starting, just to get a sense for how it's behaving. Okay, I have a little bit in the notes about nicing jobs. I think I'll just leave that for you guys to read, in part because if you're running on the SCF, generally jobs will be niced and will run at a somewhat lower priority, which is basically to share resources on the system. And if you're on the VM, it doesn't matter because you're running all your jobs yourself. But if you want to sort of set different priorities for different jobs and have one job that has higher priority, you can do it with this nicing, and you can take a look at that. All right, so let me switch over to, actually, so before I switch gears, any more questions about running jobs and monitoring jobs and whatnot?
What is ES minus AUX? I tried typing it and then I didn't get like one error.
Yeah, it's possible. Are you doing that on the VM or on the Mac?
I'm doing it on Mac.
Yeah, so it may be that the flags differ on the Mac than they do on the VM, and so you'd have to sort of look at the man page to see.
What is AUX?
So I don't actually remember off the top of my head exactly what each of those things does. I've just memorized that AUX gives me the output that I'm interested in. So again, I would have to look at the man page to remind myself of what. I think the A stands for all.
Yeah.
I don't know what the U stands for. I don't actually know what the X stands for either. Yeah, so some of this is, sometimes it's just hard to remember all the details and you need to go into the man page. And sometimes you'll just remember like, oh, this is the thing I always do, and you'll just remember the flags that you need. All right, any other questions? Okay, so another thing you can do that I won't spend any time on here really is you can set up these things called aliases, and those can just be little shorthands for things that you have to type over and over again. So for example, if you get tired of typing exit to exit out of a shell, you could create an alias called Q, and then whenever you type Q, it will execute exit. Or if you always use the -F flag for ls, you could make an alias to say, oh, actually, whenever I type ls, what that really should do is ls -F. So that's handy for sort of saving some typing. And if you want these things to persist from one shell session to another shell session to another shell session, you can put them in a file called .bashrc in your home directory, and then anything that you put in there will be available to you whenever you open up a shell. So that can be quite powerful. And if you want to get some idea of the sorts of things that I put in my own bashrc, there's this example .bashrc that's in the GitHub in the repository. Okay, so let me now say a little bit more about shell variables, which we already saw briefly. And basically the idea of these is to be able to sort of save information that you then want to use later on. And you can use these variables to basically control sort of the behavior of your code. So let's go back to the VM. Okay. So here I'm going to create another shell variable called mydir. And I'm just going to create it in the same way that we already created the variable before. I can do echo to see what's in that variable. I can now use that shell variable to do various operations. So I could say cd and then use the shell variable, and that will just change the directory to that directory. It'll just substitute again, just like we saw last time. Basically, what's happening is the shell is the one that's coming along. This is being interpreted by the shell. The shell is seeing this and saying, oh, I need to go get the value of this variable. It's plugging it in, and then it's passing the result to the cd command. Okay, so the shell is sort of doing this pre-processing before anything else happens. That's interesting. Anybody see what went wrong here? So that should have worked.
Your line directory has the tilde, which may not work for some.
Yeah, that is weird. All right, I'm not sure what's going on with that. That should have worked. All right, maybe I'll figure that out. Okay. So in principle, you should then be able to use that variable to do various things. I can do echo. If this touch command just creates an empty file, which is sometimes handy, especially for these kinds of demonstrations. So in principle, what this should do is create a file called temp.txt within that directory. That probably wouldn't work because it's having this funny behavior with the tilde apparently. So that's an example of creating our own environment, our own shell variable. There are also a lot of variables that are already defined behind the scenes, and these are called environment variables. And to see the values of those, we can do env, and I'm going to pass that to less. And so these are basically all of the variables that are defined, that are sort of controlling the behavior of the system and giving you some sense of the state of the system. So it says, for example, what the username is. So the user is this OSCE user, has a whole bunch of stuff about all sorts of things about sort of system level kind of things, most of which you won't need to know. Anything else useful in here? It says, oh, the language for the shell is set to be this English UTF character encoding business, and a few other things like that. So sometimes you'll need to make use of these environment variables, and you can use them in the same way with these as in the environment variable, as with the variable that I just created. I could say echo user, and that will indeed print out the value of the variable. And then if you want to define a variable, if I just define a variable like mydir, as I just did, I can then use it in the subsequent anything else that I do in this current shell. But it's not going to be defined and available to any program that I then subsequently run. So if I want to make it available to subsequent to other programs that I might start up from this shell window, I have to do export. So I'd have to do export mydir equals. And I think in this case, maybe I'll try it with home. I'll try to put the whole absolute path in to see if that helps. And maybe this will now work in a way that it didn't before. So now if I do echo mydir, okay, and now let's say touch mydir. Okay, so that worked. Sometimes it's helpful to explicitly sort of denote where the beginning of the and ending of the name of the variable is, and you can do that with these squiggly brackets like this. You don't always need to do that, but it's sometimes you need to, and sometimes it's just a nice convention so that the variable name sort of stands out from the remainder of the text that you have in there. Okay. And then the last thing to point out is if I say echo, let's see if I do something like this, that will return back. So let's say I do something like this. Echo my directory is mydir. Okay, so that, oops, that was a little typo there, but that prints out what I expected with the value of the variable substituted in. If I just did this in single quotes, it actually would not do that. It would not substitute in for the variable, so it'll just leave the variable in place. So that sometimes can be handy for sort of controlling the behavior of what gets evaluated and substituted in for. Okay, so I think that's all I want to say about variables for now. Any questions about that? Okay, so let's turn quickly to this idea of creating your own little function in the shell. So suppose you wanted to automate, you wanted to create a function that would allow you to do something over and over again without having to type out multiple commands. So I'm just going to give you a very quick example, but these functions could be many, many lines long. This is just going to be a one-line example. But suppose the reason that I created this one, and I actually use this in my own day-to-day life, is I just got tired of typing SCP and then a file name and then having to type out my username and the name of an SCF machine and all this and having to remember the exact syntax of the SCP command. So I'm going to create a little function called put_scf. And what this will do is allow me to basically just save some typing. And what these $signs are is basically, you don't have to, when you define the function, you don't have to explicitly say what the arguments to the function are. You don't have to say there's a first argument, a second argument, a third argument. The shell will just automatically assign whatever the first argument is to a variable called $1 and whatever the second argument is to a variable called $2, and if there were a third one to $3 and so forth. And so this will then, so what would happen when I then execute this command in the shell is it'll run this, it'll assign this first argument to $1, it'll assign the second thing after the space to $2, and then it'll go ahead and execute this line of code, or if there are multiple lines of code, it would execute multiple lines of code. And so this will then just save me a little bit of typing. So you could, for example, here are just another few one-liners where I'm defining some shorthands for running Emacs in a couple different ways, and here's a shorthand for taking a LaTeX file and converting it to an HTML file, where I just put in the options that I generally want. And so I've defined a little function called L_H to do that. So just some basic examples of creating a function. Okay, so let's now see sort of a slightly more complicated example of a function. And this is an example where we're also going to see some if-then-else syntax. So basically, the shell provides a whole little language, and we've sort of been exploring this language as we've been going through things on Wednesday and today. And just like a language will provide variables, and a language will provide the ability to write functions, and a language will provide the ability to have if-then-else statements, and a language will provide the ability to have for loops, you can do all of that within the shell. And of course, you guys have, either because you already knew some R, or because you've seen it in the boot camp or in some of the stuff that you were doing on Wednesday, you guys have already been doing that in R, and this is just the analog of doing those sorts of things directly in the shell. So here's an example of a little function in the shell, and the idea is it's supposed to submit jobs. It's supposed to submit an R job where it by default will it will nice that job, and I'm having a little bit of trouble here getting it all to fit on the screen, unfortunately. That's annoying. Okay, there it is. Okay, so what I'd like you to do is take a couple minutes and sort of stare at this or stare at it on your screen and see if you can sort of figure out what the control of this, what the flow of, if you ran this function, what the flow of what would happen would be if you ran this function yourself, and what inputs the function is expecting, and how it's using these arguments to the function to control the behavior of the function. So you're not going to be familiar with all the syntax, but take a look at it and see if you can sort of figure out what it's doing. And then after a couple minutes, we'll reconvene and see what you guys thought. Feel free to confer with your neighbors as well.
I have a question about functions. Is it just sort of, I guess, analogous to an inline shell script? Like, why would you use a function rather than a script? I can understand from like the SSH or SCP or whatever, but if you're doing something like this.
Yeah, so the idea is this is just to save the code, so if I wanted to do it over and over again, I wouldn't have to write out the script every time.
Put this in your bashrc
Yeah, so you might put this in your bashrc just like the aliases that I mentioned, and then whenever I open up a shell on my computer, I can use this function to do whatever it does.
But you would have to repeatedly use the function, right?
Well, right, but the whole idea of having a function is that it's something you want to do again and again and again. It's some
You're basically creating a new command like ls.
Yeah, yeah,
So it is
exactly.
like, that's the same idea of writing a script, is that if I want to do something over and over again, over it's script.
Yeah, you could instead of writing this as a function, you could write it as a script and call that script.
Yeah.
Either way.
Okay,
Yeah.
so it's just kind of.
To me, this might be a little bit easier because if it's in my bashrc, it's always going to be directly available to me at the command line. I don't have to worry about where in my path, where in my directory structure is the script.
Alright, that's good.
Yeah, but yeah, this could just as easily be a script.
Okay.
So suppose I write another function with the same name, would that cause a problem?
If you had two functions with the same name, yeah.
Would that override?
Huh?
Would that override?
Yeah, it would probably overwrite it. If you had it in your bashrc, it might just hide it instead of actually overwriting it. All right, so we don't have too many minutes left, so why don't I'll interrupt here. So anybody have a sense of what this syntax does?
Just checking that you get nice art.
Okay, so yeah, so this is sort of a special variable. This pound, the $ pound refers to a special variable that is how many inputs came into the function. What's your name, by the way? Alex. So it says if there are not two inputs, then it's going to echo back to the user, hey, this is the kind of input that I'm expecting for this function. Okay. So then, anybody want to guess what this is doing? Yes, and what's your name?
My name is Mo. So that line tells us if R out is already existing.
Okay, so it's checking the second argument and it's saying, as a file, does that already exist? So this is a good thing to do because then you want to check, you want to sort of figure out if you want to overwrite that file or not. So it says, oh, if that exists, that's what the -e is doing. Then it's going to exit out without actually calling the command because it's not sure that you want to overwrite the file. Okay, and then it says, okay, if the first argument does not exist, right? Then it says, hey, I have no input code file to use, so I also have to exit out. So this is just doing sort of some basic checking. And then finally, if it gets down here, then it says, okay, this is just a handy little line saying, hey, this is what I'm doing. And then you can see the use of the variables 1 and 2 here. And this is that same use of R that we saw when I was running the example a little while ago, right, with the redirecting input and output. But in this case, I'm setting this nice level, which is basically setting it at a lower priority than jobs usually run by default. And 19 is sort of a standard priority to set if you're running a job in the background that you're not that you want to set as a sort of lower priority, longer running job. This is some syntax we actually haven't seen before, but it has to do with when you write a program, you can have output come out both to standard output, which is sort of normal output, and also separately to a separate stream called standard error, which is supposed to be where error messages are sent. And usually both of those streams both go to the terminal. So you would just see both of those in anything that's sent to standard output or standard error interspersed. but there are ways to send standard output to one file and standard error to another file. And I think, if I remember correctly, what this is doing is it's sending both standard output and standard error to the same file, which is this, whatever comes in as the second argument. All right, so we are out of time. We're almost done with this unit. There's a little bit on for loops, which we'll talk about at the beginning of class on Monday. But you might want to look at it in advance because it will be useful for problem 4 on the problem set. So if you're already getting into problem 4 and wanting to be able to do it fully, then the for loop stuff here will be helpful.
Quick question. For the ampersand, I thought it was like that's like running in the background, right? And then you.
It is if it's
type
at the
it.
end.
And if it's not at the end, it doesn't count.
Yeah, I would actually. I'm pretty sure that when the ampersand was in there in the middle, I think that had to do with redirection.
Okay.
And actually, it was a little bit funny there was no ampersand at the end of that. But I guess that's because you might do nice R, file in, file out, and then yourself put the ampersand in at the end instead of having it put the ampersand in. Yeah. So yeah, sometimes symbols get used in different ways, which can be a little bit confusing. And you're one check?
Yeah.
Okay, good, I got it.
And if I want to look the whole CSV file, I can type something like this, but it's not work.
Well, yeah, because the whole idea of cut is you're only pulling out some of the columns.
So you have to specify which column you want
Yeah.
to. Oh.
Because otherwise, even if that did work, all it would do is just return back the same thing you would get from less or head or cat. You just see the whole file printed out, right? The whole point is to cut it up into the columns.
I still cannot figure out if really simple, what does that mean?
Yeah. So let's just see this again. Actually, I'm going to turn off the screen recording. Hold on one sec.